Welcome to the International Technical Webinar about saving on costs, while still guaranteeing food safety by Christeyns.
Let's start our webinar. I am Kathleen Steenbergen. As a manager of Christeyns Academy, I have the pleasure and the honor to welcome you all in this international webinar about saving on costs while still guaranteeing food safety. I think everybody knows, or everybody notices, that even after the revival after Corona, after the pandemic, this has led to really sharp rising costs. So as well as for raw materials, for transport, for labor. On top of that, the Russian invasion in Ukraine has further shaken the world chessboard, and consequently, general industry is now focusing on cost reduction as a priority. Now we notice that food industry is a really difficult context there, because first of all, they have to find a way to absorb all the increases in costs, to keep the profit margins, and not compromising on food safety. And that is where we, Christeyns, as a hygiene partner, in fact, for the food hygiene industry, we want to show you today how costs can be controlled without reducing the food safety. Now, for those who do not yet know Christeyns, maybe 2 words of who we are, what we do. Christeyns we call ourselves a partner in hygiene chemicals. We supply chemicals, but as well service, expertise, equipment, as well for the professional textile care, where we deliver, for instance, laundry washing detergents and disinfectants. We supply to the processing, the food processing and the retail sector, to the professional cleaning sector, the medical care, and the life science sector. So these are in fact the areas where we are active in. Now, we can be your partner in the entire world, with production sites distributed all over the world, with own activities or activities via the distributor. So that's how we want to be your partner in hygiene. Now, as for the program of today, we have elaborated a program where we want to touch different aspects of cost savings related to cleaning and disinfection. But first of all, we want to introduce or give the word to Mrs. Karin Goodburn, who is Chief Executive of the Chilled Food Association, and she will really explain us that we have to maintain hygiene. If we compromise on safety, that's really not a good idea. Afterwards, we as Christeyns will touch a different area of the cleaning and disinfection activities, where Fernando Lorenzo will talk about the chemicals optimization. Lieselot Ridder will go further on and explain us how we can optimize the process in the foam cleaning area, so the OPC. After that, it will be Peter Littleton who takes up the process optimization or the cost optimization in the CIP area. And Carmen Donnet will explain us how equipment automation can really reduce consumption in this in the process area or in the cleaning area. After that, Maria will clearly show us how we can use hygiene control tools to continuously monitor the hygiene level in our premises. And at the end, I'm not saying we are going to give you some homework, but Lieselot wants to give you some tips which you can, by means of speaking, really already implement this afternoon. So that's what's on the program of today. Now, before handing over to Mrs. Goodburn, just a few rules of engagement. Oh, everybody knows, I think it's already noticed on or mentioned on your screen, that today's session is recorded. To avoid all annoying background noises, we have made, or we have a setup that we can neither see nor hear you. So this also means that if you have a question, please just use the chat function, and we will have the time at the end of the webinar to handle all the questions. So then now it's time to introduce the first speaker. I have to admit, she's a very busy lady. I will not be able to give her whole resume, but at this moment, she is director of the Chilled Food Association. She specializes in the chilled food sciences, the technology and the regulatory affairs. As a consultant, she also advises governments. She provides technical guidance to manufacturers. She represents the industry both in UK and around the world. She also has overseen the development of numerous industry guidelines. She's involved in negotiation, interpretation and implementation of European law. And she is a member of a range of well-known boards and committees like the UN FAO, the WHO, GFSI, UK government and its agency, the British Standards Institute, the European Chilled Food Federation, and I could go on for 5 minutes more, but I think the story she has to tell is also will show us that the experience she has. So, Mrs. Goodburn, thank you already for being there, and if you want, you can take control and take over the screen.
Okay, Karin, from the Chilled Food Association, I'm going to focus particularly on, well, the issue of where can we cut corners? Is it worth the risk? What are the risks? And some examples of things that can go terribly wrong if things aren't done properly. I'm going to focus on hygiene in particular. Of course, this is a hygiene seminar. Are there proven options that you could think about? What are pitfalls? And I'm going to really focus on high risk foods, which are chilled, ready to eat foods, supporting the growth of pathogens, because that's what we deal with. So, and here we can see bottom left one, the world's largest sandwich factory, in case you're wondering what it is. So Chilled Food Association is a trade association in the UK for manufacturers of chill prepared foods. I'm not going to read everything here. There's some definitions. All my slides have got quite a lot of information, but I'm not going to I'm going to speak to them, not read them out, which I think you'll be thankful for. So this will be circulated later, I understand, so you can indulge yourself with data and text later. So most of the important thing for us is that the vast majority, more than 95% of chilled prepared foods in the UK are sold under the retailer's label, Marks and Spencer, Sainsbury's, Tesco, Asda, Waitrose, and so on. There are very few notable manufacturer brands, so we are very much working to retail best practice standards, and it's pretty demanding. So if you're not doing a retailer supplier, so you're not supplying M&S and the rest of it, you probably haven't experienced pain, but it's all worthwhile for protecting the consumer and therefore protecting the industry. And we work on safety, standards, research, science, and sustainability and skills, all sorts of S's we involved. So some things that you can possibly think about: reducing costs and look at for reducing costs. Reduce the energy use per kilo of food. Okay. Reduce water use per kilo of food, because also water isn't necessarily used cold. It can be used to heat things as well. So there's energy involved in that, as well as just resource issue. And like other countries, but the companies are on water meters and things here, so you pay per ton of food. You could try using cheaper raw materials. You could clean less thoroughly or change your biocide to something not quite as expensive. You could reduce food loss through waste, so longer lives, for example. Increase production efficiency and reduce lost time for changeovers between different products on a production line, because each of our factories are making 40 to 50 different foods a day on half a dozen plus lines. So there's a lot of changeovers and chilled short shelf life. You could change the final product packaging or the process or formulation even to try and reduce costs. So what are negative consequences? Because as we say, there's no such thing as a free lunch, and you must consider various things fully in relation to each of these areas and effectively address them. I'm going to zap through this, so hold on to your hats. So what makes food ready to eat? So I'm going to focus on ready to eat food, supporting growth of pathogens. It's high risk food. So you've got to design the product correctly. You've got to have a full HACCP plan that actually delivers safety as well. And it starts for minimally processed foods, which I've got a picture of some salad in the bottom right. If you're going to have raw ready to eat, you have to grow it right. And the growing and production controls need to be validated and monitored. There aren't CCPs in raw ready to eat food, and that includes cold smoked fish, for example, that's ready to eat. So you have control points instead, but you validate and monitor. Hygiene, preparation and packaging and packing, that's validation and monitoring as well. We want to prevent or cross contamination, because thermally processing the pack, which sounds great, unless there's a problem with the cooling water or the seal of the pack, for example, or there's some sort of abuse. Limited shelf life, and we have about 2 to 10 days as a standard shelf life for chilled foods. Can go a bit further using the Sussel process, which I'll refer to. I'll tease you all about that one, but I won't tell you much about it. Chilled distribution, sale and storage, we're working at 5 degrees maximum to the retailers' regional distribution centres, and that they require that commercially and will reject food that arrives at more than 5 degrees. We know that fridges are running possibly about 7 degrees, and I put the reference for the Food Standards Agency project that surveyed that, and guess who did the work. And appropriate usage instructions, and this is to protect the consumer, and we're really on use by date territory for these sort of foods. So that lot translates to the 4 C's, which is what everybody should be reducing things to and making sure they address as an absolute minimum. And these are defined, it's defined by the United Nations, by everybody. And these icons are from the IAFP, in case you're wondering. So everybody should be following this. And anything that anybody says, oh, we've got to do something special for listeria or something, is actually just embellishing this. You've got to get this stuff right. And it doesn't matter about the pathogen, but I will focus on listeria here. So 4 C's, clean. So remove soil and protein before applying surface biocide, decontaminate produce. You cannot remove pathogens from produce if they've already harpooned themselves on. You can reduce the overall TVC or ACC, but you can't rely on washing to clean produce. Then cook. And there are several processes which are recognised. European industry recognises 70 for 2 minutes. And we have 90 degrees for 10 minutes for a non-proteolytic Clostridium botulinum control, or 121 for 3 minutes, which is a canned process, or the Sussel process, which is a special thing that we developed for chilled foods for a medium shelf life. Avoid cross-contamination through segregation of raw and cooked. Keep things cold, and I'll just say that bacteria grow a lot quicker from at 8 degrees than they do at 5 degrees, and particularly listeria here, twice as fast growth at 8 than at 5, and 3 times as fast at 10 degrees than at 5 degrees. So getting rid of some refrigeration to save energy consumption is going to cause illness, and that will affect you and your company, and of course may result in death. So we're not going to do that, are we? The 5th rule is use good quality raw materials, and that is absolutely critical for raw minimally processed foods. You can't clean it up. So listeriosis, so a bit of this. So this is the commonest cause of foodborne illness related death in Europe, but not in the UK. And I like to think that the systems we set up in the UK are protecting people, and that was the difference. So we can see on the right here, there's a scan of somebody's head with, this is a big infection. This is pus, an infection in the brain. And that sort of thing is going to change your life if you survive it. So we get septicemia, meningitis, spontaneous abortion, and there's also birth of children. There's a baby here with a skin listeriosis infection, but it leads to stillbirth as well, quite commonly. Hospitalization rate really high, death rates are high when you get these the septicemia-based infection. Listeria monocytogenes is the proven foodborne food pathogen. Human pathogen, long incubation period of up to 3 months, so that's difficult to be asking people 3 months, what did you eat? And the sequelae, which are not often talked about, so these are the lasting impact of disease: seizures, paralysis, impaired ability to see, hear or speak. So it's not just number of people who had listeriosis, it's what's their life like afterwards, as we thought about. So listeria is quite a beast. It's one of 26 species. It's outside, it could be on your shoes. 10% of people who work in certain environments, say closely with animals, could be expected to carry it. It grows in the fridge, survives freezing, so frozen foods have to think about it too. Doesn't mind if there's no oxygen, so vat packing doesn't really impact on it. It survives 20% salt solution, and it grows even in cured foods. A big thing from a hygiene perspective, it forms persistent biofilms and surfaces, and they're quite resistant to cleaning, disinfection. They're a reservoir contamination, and you must keep on top of hygiene to manage it. That means monitoring hygiene as well. Then vulnerable groups are particularly susceptible to this organism and the illness, and the transmission is primarily through food. So it's down to us to protect the consumer. So vulnerable groups, I'll just say here, there's a lot of people who are in vulnerable groups. Anybody who has a stressful job and is taking antacids is in a vulnerable group. There's a Dutch paper on that one, which I'll put the asterisk there for. And the proportion of the population in the vulnerable group for the USA and the UK is estimated to be 20%. And when you think that the population USA and UK is about 370 million, it's probably about 75 million vulnerable people in the USA and UK. So this is really significant. Of course, you carry that forward to whatever part of the world you're in. And then there are other countries which have even higher vulnerable group populations, say where HIV is endemic. And there's a very unfortunate, massive incident that I'm going to refer to. So listeria, if you look on the right, fatality rate of listeriosis compared with other, shall we say, popular foodborne disease is much higher. So this is a nasty organism, and it kills. And this is for you to just absorb later on. In the red is the countries in Europe that are above the European mean rate of listeriosis, and I'm thankful to say that the UK and Ireland are actually below the mean and consistently, and we're about half of the European mean. So we can see that it depends on the food that is eaten and the culture, and the culture is the food. The food is the culture, at least part of it. And so I'm half Finnish, and the Finns have particularly got a problem, and it's a lot of ready-to-eat raw fish that's is indicative of being the issue there. And other countries where there's that sort of consumption of proteinaceous food with long shelf life. And perhaps tapas, which lovely tapas bars. A glass of wine is not going to kill listeria, I can tell you now. And nor is schnapps, if anybody's thinking of something different. And all the charcuterie type of cultures and smorgasbord cultures and the tapas cultures, they're in the top league for listeriosis in Europe consistently. So that's what we want to control. We don't want any listeriosis. We don't want other diseases either, but this will focus on listeriosis. And look at these just zapping through. Reduce energy use per kilo of food. Well, there are validated processes required to reduce pathogens and spoilage organisms. I mentioned a few. So you can't skimp on that if you want safe food. Cooling. If you don't cool rapidly enough or sufficiently, then there's risk of bacterial growth. For example, Bacillus cereus. So that is a danger in itself. That organism won't necessarily kill you, but it's very unpleasant. And if you're already ill with something else, it's not going to be good. And there are other organisms such as Clostridium perfringens, which do regularly cause deaths. So cleaning, if you want to reduce energy costs through steam or other heating or other forms of cleaning, then there's a risk of contamination leading to biofilms. And the other thing I'll just mention in here, it's not really in place here, but you must carry on sampling. Don't save money on not looking for organisms. There's also transportation, including product conveyors and things, which could be an energy cost you can look at. Reduce waste, reduce water use per kilo of food. Can't just recycle and reuse water without considering the micro quality of it, and even other contaminants, shall we say, organic contaminants there. So, and that applies in the field onwards. Good agricultural practice standards can't be compromised. And if we have water shortages, that's a bit of an issue. You have to treat water going on to raw ready-to-eat crops. And we have a sort of league of risk for different types of leaf. And if you're using water in contact with food or as an ingredient, or even non-food contact, you have to protect the food from potential contamination that's present. So recycling without care or treatment is not on. And note that listeria loves water, and it spreads through aerosols, so don't spray water around factories. Really don't. You'll contaminate everything. Cheaper raw materials. Well, how do you know where it came from, what the risk is associated with it if you change for something cheaper? Really, what's happened to it, and why is it cheaper? It's a good question to ask. Why is this cheaper? And note also for fresh produce that if the produce is damaged, then that increases the micro risk, and it's not going to last as long. The quality will be lower because organisms will have got in, and they can be pathogens as well. I'll come to clean less thoroughly or change biocides. So I'll leave that for now, but I've already mentioned a bit. You can reduce food loss by extending shelf life. I know I've already mentioned thermal process. You could do deep chill. That takes energy, but it preserves the product. High pressure pasteurization. Bacteriophage I'm quite keen on. Could that be used somewhere? Not legal in the EU for products of animal origin. You could change formulation or do something else, or all of those, perhaps a bit of irradiation, something. Those sort of things about stopping wasting food when it's cost energy to produce it, and you've invested a lot of time in ensuring the supply chain is correct. You can increase production efficiency by reducing number of changeovers, such as doing longer runs, but that needs longer shelf life. So for short shelf life food, longer run means you're going to have to sell more of it. And certainly in our industry, we have a lot of handmade foods. We're making a lot of different foods each day from factories. So we're not making 1 million units of a lasagna and then waiting for somebody to buy it. They're made to order. So we're going to have to talk about longer shelf life here to try and reduce the number of changeovers, increase the volume per batch. Then you're going to have to store work in progress and so on. And that costs energy and space. So be aware of that. And I already mentioned final product packaging and post process is possible, like another layer of pasteurization on the product when it's finally in the pack. But that does have a quality impact. So that's rushing through things there. So focusing on the clean less thoroughly or change biocide, you have to talk about biofilms. And I mentioned Listeria loves doing biofilms. It's not the only organism that does it, but this is a deadly pathogen, and we are focused on it in this industry. So you can get within seconds to minutes the organism attaching to surfaces, and then they start to produce extracellular polysaccharide and protein that sort of glue themselves on. And it doesn't necessarily have to be a pure biofilm of Listeria monocytogenes, with other things having a party with it too. And it will grow and grow. A nice bit of protein floating by in somewhere that you can't clean easily. It's a classic thing to happen with Listeria, and ultimately the biofilm can break off and spread around the factory, and you've got real problems. And consider these biofilms are glued onto the surface. It's very difficult to get on top of once they're established, which is why you have to keep on top of hygiene and keep monitoring everything and all the difficult spots that you can't really necessarily get to without dismantling kit. So we're talking about dismantling equipment here on a regular basis, all driven by the risk. So biofilms are a big issue, need to avoid them. And we want robust hygiene systems, clean, disinfect, validate, verify, so on. The other thing is you must not waste biocide by putting it on surfaces that have not been cleaned of protein. So it's a whole table here showing the effects. On the green, it says effective cleaning and removal of protein residues before applying. For the bottom row here, quaternary ammonium compounds. It's a 1,000,000-fold reduction. This was artificial inoculation, and it's much reduced if you don't clean off the protein. The same applies to other biocides. So clean off the protein first, otherwise you're wasting money on your biocide. Taking that from Safe Smoke Fish Tool from Food Standards Agents Scotland, which is a very good website. What I got down, my thing's frozen. Come on. Next. Right, so what does good look like? Well, I mentioned you must do monitoring, and we do a lot of monitoring of surfaces and food in the UK chilled food industry. So these are headline data from 12 years. We collect this on a monthly basis, and we've collected food data going back to 2003 and environment data back to 2006. But we just talk about the last 12 years because I can't fit more on the screen. So we see that over 1 million samples of food have been taken in the last 12 years by CFA members. And we found less than 0.7% presence of Listeria mono at any point during shelf life. And we really are looking for it. You really are. I mean, if you're doing too few samples, you're not going to find it. And my assumption is it's always going to be certainly in the factory, if not a food. So the amount of quantifiable Listeria, so that's more than 20 per gram, is 0.0001% of those samples. So we've got very low counts and presence of counts. And on the production environment, we split it into food contact and non-food contact, and there's nearly 2 million samples here for these 12 years. And for a clean, this is what good looks like, basically. So for a clean food contact surface, it's about 0.3% of Listeria monocytogenes. That's about 1 million samples of each of these, and then non-food contact on the floors and so on. So we collect these data from our membership on a voluntary basis and use it for benchmarking. And then I want to know if why any site is above any of the CFA norms in any one year. And I've already said it gives a high level of public protection. So you can see our listeriosis rates brought down the European rates when we're a member of the EU, and we're below, well, about half of what European rates are for up to 2020's last data. Lots of outbreaks of listeriosis. Look at post-process hygiene and contamination post-process is a feature. And I'm going to talk about these two incidents, which are notable, just as examples. So the first one here, the South African listeriosis related to Tiger Brands Enterprise Foods French polony, which was processed in the pack, so therefore should be safe. So it's a ready-to-eat food, and it's a staple food. And it's eaten widely around southern Africa. And unfortunately, something went desperately wrong here, and there are over 1,000 lab confirmed cases and over 216 confirmed deaths. And they were really reported from Durban, Johannesburg, and Cape Town. So who knows what was going on in the rest of the country in the rural areas. So you can see it was mainly infants less than 28 days old who got it and died. 91 died. And then we had well, it's really their mothers. So it's pregnant women and other adults, and the older age group was relatively underrepresented. So this killed young people and the mothers in particular. So this is a hypervirulent strain. We got a contamination post-process. So something was wrong with the hygiene to contaminate these foods. There's a long shelf life, so plenty of opportunity for listeria to grow. It's also highly proteinaceous, and it's got a 20% HIV rate in Southern African adults. And there are so many issues there that came together all at once and resulted in destruction of the market, deaths, and legal cases and court cases still going on, and a revision of all of the standards. So here we are, we got a contaminated high-risk long shelf life food eaten in a staple food in the country with high percentage HIV positive, lots of vulnerable people. There was a vast increase in factory inspection by WHO, etc. Health inspectors retrained and taking samples from factories. New legislation brought in requiring HACCP and LM not to be detected, which I would dispute really whether drives stuff, because it tends to make people not test. And then 2 years later on, this was 2 years ago, Tiger Brands sold to the factory, but it's still being sued, and there are 216 children, mothers, fathers, sisters, brothers, friends, colleagues dead, and thousands of people bereaved, and long-term sequelae for those affected badly in particular. So you think about our responsibility in the food industry, and this is it, not to let this happen. Then another fatal listeriosis, this was linked to frozen corn. And this ran for a number of years, was detected through whole genome sequencing and pooling of data. There are half a dozen countries, well, 5 countries involved in it, and 9 deaths, 47 cases. And we've got a picture of the stuff here, which is sweet corn in Finnish and Swedish. My mother was a Finn. She used to throw frozen peas into salads, and it is not grown to high care standards. It's not handled to high care standards, and high care standards are required for raw ready-to-eat food. So this is things that people are doing that they shouldn't do, and they're not following the instructions because they don't understand the risk. So here, what happened? Well, frozen maize is high sugar. There's a cut surface where you cut it off the cob, and it's the food supports the growth of Listeria monocytogenes. The blanching will deal with the surface contamination, but will it get into the center? There's potential for post-process recontamination because the factory was not designed to be not producing a ready-to-eat food, so it was considered to be low risk. And there weren't even criteria that applied to those foods in EU law. It's not treated as a high care food from field to processing. It's not treated like we would treat a lettuce, for example, in this country, because people are supposed to cook it, and the advice was cook it for use. And the thing that worries me about frozen and people making smoothies is it's going to happen one day. So the factory invested a lot in improving its systems. We can see in the middle picture here, this is not what we would consider in the chilled sector to be segregation between a high care and lower care area. We need walls. So it's still not quite what we would expect in the chilled sector, but there's a lot of investment and they've changed their systems. There's you can see there's actually investment in kit as well. And they're doing a lot of swabbing now for the environment, for monocytogenes and for the product. And they're implying a criterion of less than 10 CFU per gram in imports to the UK. So big changes at that company. Then if you do my funny little table, which is something I just make up, this is not sort of published or anything, look at the factors that should be controlled and how's either of these incidents with South Africa and the frozen maize, has actually demonstrated that these things are under control. And for every false, you score -1. For every true, you score +1. And if you don't know, put a 0. And so the big things here that the manufacturer can really control is the hygiene has managed to prevent recontamination, which means cleaning as well. And other things are sort of characteristic of the product, and then who is eating it at the end. So just running down this list, South Africa scored -6 out of possible good score of +9. And the frozen maize on my scale scored -2. So both had great room for improvement. It's good to see room for improvement, certainly on the frozen maize and hopefully in South Africa too. And just to summarize, because I know your time is short, compromise hygiene or any of the 4 C's at your peril. And please note that short-term decisions and even medium term can have life-changing long-term consequences for the consumers of your food, for your business and for you. And we're talking court cases and things, and just being able to live with yourself if you knew you cut a corner somewhere. Or it was done unintentionally. Are your HACCP plan sanitation and monitoring systems consistently effective? Is the law actually putting you off looking for something that you ought to, which is one of my bugbears? And for me, why are all the previous lessons for decades of issues not being cascaded more effectively? So hence why I'm agreeing to do this. And that's within the industry through trade association, profit bodies, and then Christeyns and other companies, and by and to customers. So the manufacturers and retailers. Manufacturers are often customers themselves. They need to push back and get the standards in place from their suppliers too, particularly for ready-to-eat components. But I'll just repeat, compromise hygiene or any of the 4 C's at your peril, because it can be absolutely disastrous on every level. But there is help, and I've just put this massive table of guidance together, so feel free to click on those links when you get a copy of this. I think it'll be a PDF. They should work. Some of these you have to pay for, but a lot of the CFA stuff that I mentioned there is free. And that's it. And hopefully that set the scene for everybody else for the rest of the morning.
Let's go further now with, or I will hand over now to Fernando Lorenzo, who is our R&D manager for food hygiene, and who will in fact explain us how the raising or the cost savings can be done, or what we can do in the field of chemicals optimization. Fernando, the word is yours.
Okay, thank you. Good morning to everyone. And I want to start thanking Karin for her very good presentation, because she made a very important point. We are talking about food industry. And when we are dealing with food hygiene, it's important to know that cleaning less is not always a viable option. So we need to think of ways of cleaning better. And for that, the right choice of chemicals can help us to decrease the overall cost of hygiene, but also making sure that the main target is to have good efficacy, good results on our surfaces. I will provide a little bit of background on why chemicals have become more expensive, and I have to say that it's going to be all bad news, but I'm going to provide some tips and solutions later. So we all know, we are all aware that the raw materials have become more and more expensive, and they continue to become more expensive. And this is due to how they are produced, where they are produced, and how we get them. So energy costs, most of especially the basic raw materials like sodium hydroxide, sodium hypochlorite, etc., depend a lot on energy for the production. And we all know that gas and electricity prices have increased a lot, so that has a direct impact on the cost of the raw materials. And And also the transport costs have increased due to petrol price, the prices of petrol, and also the cost of shipping the containers. Also, they have gone down a little bit in the past. But of course, we need to bring the raw materials from other countries, other continents, and that's the cost of transport has increased a lot. And also in combination with the higher cost, there have also been problems of availability. So we have factories that have been affected by natural disasters. We have had a lot of lockdowns due to coronavirus in many places. And we have, unfortunately, armed conflicts in some places where we have production of raw materials. So that means that they are less available, and consequently, the prices go up. Another important point is that it's the basic raw materials, the precursors that have been affected. So that means that they have a negative impact in the whole chain. So if you have problems with precursors, all the raw materials that are derived from those precursors, like surfactants, for example, increase in price consequently. And if you look at all the components that we use in detergents, all of them have experienced very high increases in prices. Not water at the moment, but that will come probably. Okay, when we think about the cost of chemicals, we need to think also about the overall costs of hygiene. This graph here is a rough distribution of how the costs of the different components of hygiene are distributed. So chemicals, in fact, amount to a small amount of the overall cost, maybe 5 to 10%, depending on the process. It's due just to the purchasing of detergents and disinfectant. Then we have a cost of water, the water that we use to dilute the chemicals, and also to rinse the surface and to take the residues away. We have a higher cost in energy, the energy that we need to pump the water and the chemicals to the application point, and also to heat it, especially in CIP processes where we need to, or washing tunnels. But the biggest cost is normally time. Time includes labor, so we need people applying the chemicals, and that's a big expense. And also we have a production downtime. So all the time that we are cleaning is time that we are not producing. So it's not a direct cost, but it's a revenue that we are not getting. So we need to see, so according to this distribution, the cost of chemicals is actually a minor part of the whole hygiene process. But the right choice of chemicals can have a significant impact on all these aspects. Chemicals can help us to save water, to save energy, and to shorten the time for hygiene. And we will see some examples, and then the following presentations will be more focused on these aspects. So what can we do from the chemical point of view to decrease the overall cost of hygiene? So basically, if we are considering only the chemicals, the chemical part, we have mainly two options. We can use cheaper chemicals to have cheaper products, or we can try to have smarter formulations. With the cheaper chemicals, which is normally the easiest options of the option that industry tends to look when they are buying products. So we can lower the concentration of our components in the detergent or the disinfectant. We can use fewer components. For example, we can remove some of the sequestrants, some surfactants, etc. Or we can use cheaper components. Unfortunately, this is not always very efficient, because this graph also shows roughly the relationship between efficacy of a detergent and the cost of chemicals. So if we go to the lowest cost of chemicals, let's say water, cleaning efficacy in most cases will be very low, almost zero. As we increase the cost of the chemical, we rapidly get to an increase in efficacy, and then we reach a point in very high chemicals that we are not really getting much more efficacy with the increased cost. It's only for specific applications. So what happens if we use the detergents on the lower cost side of the graph? in many cases, we can have unexpected problems like corrosion, scale precipitation, residues on the surface that are difficult to rinse, foam not adequately controlled, so the product is not very foaming in open surface applications, or it's too foaming in CIP applications, or we can have a higher hazard classification for the product, for example. If we are in the highest cost part of the graph, in some cases we can be just too over expensive. So maybe we are not getting the right efficacy from the cost of the product. This is in general, of course, for the specific applications. We may need some very specific products that can be more expensive. So we need to try to work in this optimal area where we are not having over expensive products, and we are not compromising the results of our hygiene process. A good example of this is the use of alkaline chlorinated products. Alkaline chlorinated products are very popular in the market because they are cheap, or they are cheaper than other chemicals. They are very effective at cleaning, especially organic residues like proteins, and they are a very effective biocide as well. However, if we rely only on alkaline chlorinated products, we have long-term or medium-term problems, like the fact that they are very corrosive. We can have corroded surfaces, and that's very bad for food safety. They are more hazardous to the operators, and in some cases, or in some industries, they can produce chlorate residues, which is not very good for the food either. So the second option is to try to work with the smarter formulations. With the smarter formulations, we are talking about optimizing the formula to get the desired effects with the minimal cost. And in this case, we are looking at finding synergies between the components, so that we can have a better scale prevention, for example, better foam control, or better biocidal activity just by mixing different chemicals that together have a better effect than when they are on their own. And it's especially important to use formulations that are very tailored to the applications. So we need to understand our application. We need to understand the residue that we want to remove, how we can apply the product, what equipment we have, temperature, etc., and try to find the best formulation for that application. So very quickly, I will provide a few examples of when a product that is in principle more expensive can lead to cheaper hygiene costs. So we are trying to solve this equation. So higher cost normally doesn't mean cheaper, but in many cases, the use of higher cost chemicals can lead to cheaper hygiene processes. And as we have seen, it's the overall hygiene process cost that we have to consider. One example of this kind of chemicals is the formulated caustics that we use for cleaning in CIP. In some cases, it's very common to use just the raw material, sodium hydroxide 50% to clean. This is a very cheap, or used to be very cheap. It will increase in the future. So this is a cheap way to have a very strong product that can remove organic residues from the facilities. If we consider the product below, and we look at the alkalinity compared to the cost, alkalinity per euros, we have a product with less alkalinity, so it's not so strong. And we have added some other high-value components like surfactants, sequestrants, additives, etc., that increase the cost of the product. In the first case, we have a product that is lower cost per kilo, but we don't have any capacity for foam control. We don't have any capacity for scale prevention. And we can have freezing issues, for example, in very low temperatures when we are storing under 5 degrees. In the second case, we have a product that on paper is more expensive per kilo, but we have better, it's more efficient at controlling foam, at preventing the formation of a scale. And with the right choice of components, we can have synergistic cleaning. So actually the cleaning efficacy is better than the sodium hydroxide on its own. So with the first product, initially we have a cheaper product, but it can lead to longer cleaning processes. So we have more time to clean. potential issues in the long term, like production of foam, depending on the residue, and the production of scale deposits. And it may not be effective at removing all the residues. So we need to look not only to which product is is cheaper on paper, but which will provide the better efficacy for the cost. Another example is with enzymatic cleaning. Here, usually enzymes have the activity of enzymes is very dependent on temperature, and usually the enzymes that we use in cleaning have a optimal temperature between 40 and 50 degrees, where they show the best activity. This is the case of one of our products, MidANC 1000, which is a product for a foamy detergent for open surface cleaning. This is made with a synergistic combination of enzymes, but we can use newer generations of enzymes that can work in a wider range of temperatures. So we have variations of the product which are a bit more expensive, but can work from temperatures of 20 degrees. So that means that you don't need to heat so much water, you don't need to apply so much energy to the process, and it reduces the cost of the hygiene overall. Last example is for example, to formulate detergents and disinfectants which are easier to rinse than conventional products. In this case, we avoid using components that are difficult to rinse, like silicates, for example. We look for specific combinations of surfactants and solvents that can help to rinse the products from the surface and the surface to dry faster. And we also add components that prevent the scale deposits and redeposition. So that means overall that we have shortened hygiene time. We have to rinse less the surfaces, and we prevent the redeposition of residues after cleaning. So we have better hygiene results overall. Okay, just to summarize a quick summary of my presentation, a few points to take home. Of course, R&D is essential to decrease the cost of chemicals, and we are working hard in trying to have the lower cost for our products. But we focus on the ratio between efficacy and cost. As we have seen, efficacy is very important to make sure that the hygiene results are good. So it is then important to have the right choice of chemicals to minimize other hygiene costs, like the amount of water that we use, the energy that we need to apply in our cleaning process, and the time that we take to clean and disinfect our facilities. And for this, it's very important to have the right technical assistance to help us identify which chemicals are the best for our applications and for the conditions that we have to apply our products, the equipment, how trained is the personnel to use them, how can the tools that we have to validate the hygiene process, etc. So that's basically the summary of my presentation. As a final point, as this is a reminder of what Karin has explained before, most important, food safety is always the main goal in hygiene, and bad hygiene can be cheaper in the short term, but can become much more expensive in the longer term. Thank you, everyone.
No, thank you, Fernando. I think after reflections over product use, chemical use, and not chemicals seen as a standalone cost center, but really in the global aspect of hygiene cost, I think, Lieslot, you will dive now into the foam cleaning area and explain us or give us some examples on how we can optimize, let's say, the process to save costs in open pan cleaning. Okay, Lieslot, you can take over. Thank you.
Yes, indeed. Thank you. Okay, yes, following to what Fernando just told, we will talk a bit more about how we can turn this into a practical situation for OPC cleaning or open plant cleaning. So actually what we need for a process optimization in this type of cleaning is, first of all, actually the knowledge of cleaning of the cleaning program, how they clean, the times, which products, if it's every day the same cleaning program or not. then followed by the different weight of cost, because of course you want to make some savings. So the starting point is to know where you spend your money on today. So as also explained before by Fernando, most of the costs actually go to time, labor time and downtime for production, followed by actually water, energy, and then of course also chemicals, not to forget. Specific limitations, also to consider if you are going to optimize, of course, limitations in time, cleaning time, more pressure from production to produce more hours. Otherwise, there can be also limitations on water availability, hot water availability. So all these things you should take into consideration before you change anything. And maybe the most important one is the time to observe. Of course, if you don't take your time to see what's happening and to find out how you can solve it, it won't work. So you need to take your time, even if you work with just follow-ups or with the monitoring tools, it will require time to make changes and to validate and to see if it's better after all. And as a guidance in this whole process, we advise always to use the sinner circle in the first place to evaluate what is going on and also to optimize and validate afterwards. I will give now some examples based on some graphs coming from our monitoring tools to reflect actually what you can do in practice, or some examples of what you can change in practice. In this case, you see that someone has the green bar or the green part that you see in the middle is actually a guy who was a person who was foaming. And after that, he actually didn't do anything. So there was a room with one satellite for foaming, for cleaning. So he went in, he foamed, and then he probably left for the next 4 hours to clean maybe another room. So actually the foam was soaking the soiling, and then after a while it started drying again, soiling dried again on the surface. And then after 4 hours, he came back, started foaming again before he started rinsing. So actually this first step, how small it was, it's a waste of time, a waste of water, and a waste of chemicals. And then as a second example, we see again actually the same graph, but here we talk about the water consumption. The graph is on the right side, but the numbers are on the left side. So actually this person was rinsing with water at 70 liters per minute, while the system usually provides 40 liters per minute if you use the correct nozzle. Which indicates that you almost double the consumption of water. And you should also consider if everyone in this factory would start doing this, the pumps won't arrive or won't manage to keep up with the pressure. So in the end, you will also use mechanical action. So it's a really big focus point where you can save a lot of water is actually use of the correct nozzles. Another example of something that we see very often, or we detect very often through our monitoring tools, is the difference in the amount of water between different days, and also the amount of time that was spent on cleaning. This is an example from a customer who actually has the same cleaning program all week, and the same people cleaning in the same room, same production all week. And so we noticed that in 2 areas, area 1 and 4, sorry. They managed to do a very good cleaning. I don't know if it was very good, but they managed to do the same cleaning with the same products, same cleaning program on Friday with a significant lower amount of water. So 2,000 liters of water, for example, compared to the other days around 6,000-7,000. And also they managed to do the complete cleaning in only 1 hour, where the other days it took around 3 to 4 hours. So it could be that they have a magical forces on Friday, but we would always advise to take a good look at the microbiological results, the visual results of this cleaning on Friday, to see if they are taking too much time the other days, or if they are doing too quick cleaning and not detailed enough cleaning, or don't follow the correct steps on Friday. So actually we have some monitoring tools, as mentioned before, the Insight OPC monitoring tools. We call them the next level in your OPC. So of course, as mentioned at the beginning, it's very important that you always start from knowing what's going on in the field. If you have the graphs without the knowledge from the field or how they actually work, it's very difficult to evaluate. So these monitoring tools actually control approximately everything. So the working times, the water consumption, temperatures, chemical consumption, also the chemical concentrations. And it's a perfect tool actually because you keep up with the records of each cleaning, each treatment, even the consumption of water or the use of water during production. And you can also set up alerts if some limits have been passed. An example where you also can use these monitoring tools for is actually to validate what the result is of your improvements or your new implementations. This is an example from a customer where they had a very high water consumption, a problematic high water consumption, and so through raising awareness and training in the weeks as from week 31 we started, we really saw a significant decrease in the water consumption at this factory, and it remained low. So it's not a temporary effect. Of course, it's a continuous job to keep the people aware and to follow up, but you really see a significant decrease of the water consumption at this customer. Also about the tools, the monitoring tools. So there are from all levels. So actually there are very complete installations with central systems, or also the decentral systems, which are easy to install and extend in, for example, smaller companies. Like this, we can support or we can supply them to each kind of company. So it's not only a solution for very big factories. They are easy to install in existing equipment as well as for new equipment. And they are suitable to be installed by the technical team from the company themselves, or also by our engineering team. So it's a very flexible package of options we have. And then at last but not at least, I think this is a very important one. I want to promote the tools, of course, but I want to highlight as well that it remains important to follow up and to know what's going on in the field. Some people think we have the tool now, so we just continue watching the graphs and we don't enter in production anymore. Then you could make the mistake. Here you see that the person was foaming 2 times, and there was actually not even a 15 minutes contact time in between, not even 5 minutes between the foaming and the rinsing. So you could think, okay, he doesn't respect the contact time, but actually when we went to the customer to see how this person was cleaning his area, we noticed that he was actually foaming one side of the room, went to the rinsing of the other side of the room, foamed then the second side of the room, and then went back rinsing in the first part. So then if you calculate the contact time, he really respected it. So it's really make sure that you know how the people clean before you draw your conclusions. So that's it for my first part.
No, it's not okay. Thank you. I think you have given the example of what you do not measure, you cannot manage. Yeah. But on top of that, I think your last slide, it's not only measuring and managing, it's also observing, going into the field and, let's say, take the conclusions of what is happening there. I think Peter Littleton will take over now. He is the Christeyns UK Technical Director. And I suppose you use the same philosophy when explaining us how you can optimize the cost in the CIP area.
That's quite correct, Kathleen. Thank you very much.
That's what I thought.
And good. Yep. Still good morning, everybody. Thank you for attending today. So I'm going to take a quick gamble through the area of process optimization for CIP, really building on the information that Liselott just provided us for OPC. Whether you've got an automatic SCADA controlled CIP system, or if you're on traditional manual systems, when you're looking at the CIP optimization, it's about looking at all those parameters. It's not just focusing on one individual area. It's about looking at the whole of the CIP system through time, water, energy, chemical, carbon footprint. And sometimes it can be quite surprising that the bigger savings can actually come from unexpected sources. And I'll introduce a case study a little bit later, which will pop in the chat as the webinar progresses, just so you can have a little more detail on that. But if you are looking at CIP optimization, we're looking at the total cost of clean reductions. as we've already heard extensively today, focusing on one particular area really isn't going to give you the biggest picture in terms of reducing your cost of clean. You can also find through optimization that you can reduce your cleaning time, and that can be very, very beneficial to your production process. I've yet to find a production process which has a excess of time. You know, no production manager has ever said to me, "No, don't worry, don't save me time. I'm fine." You know, we've got loads of it. So everybody needs more production time back. So if you can optimize your cleaning to provide more time back to production, you enable better efficiencies. You also make friends, which is great. We can look at product quality and the integrity of the product, as Karin has already talked about and Fernando mentioned, and a little lot as well. You know, if you get hygiene wrong, you will cause negative impact on your end consumer, you know, either through quality or integrity issues. You can improve your environmental footprint. You know, we're all looking at ways of reducing our energy, reducing our CO2, reducing our environmental footprint on an impact on the environment. So improving that is beneficial. And if you're looking after your equipment properly and cleaning it, you're reducing stresses and strains on motors, valves, etc. So you reduce downtime and enable yourself to carry out better planned maintenance. Now, we have a piece of software called Insight CIP, which is the brother of Insight OPC. So this looks at the specific CIP system, and it's something we've run for many, many years. It's clear to understand, though, that it's verification and monitoring software. So it is purely looking over the shoulder of your control systems to make sure that everything is working the way you expect it to. It's not control software. It doesn't interfere or interject into the process. It provides you information that you can then use to optimize and control your CIP, but it doesn't take over for you. It's not an artificial intelligence system. And many of those control software systems are called SCADA, or referred to as SCADA systems. What Insight CIP will do is take signals and information from throughout the CIP set. So if the valve, if the pressure meter, if the flow meter, if the thermometer has a signal, and is controlled through a PLC, get my teeth in gear, then we can call information from that. Both the fact that it's happened and also what the exact data was. And this is where, again, it does differ from the information you'll receive from your control software. Your control software, for example, will say, yeah, we achieved temperature. Insight will tell you what that temperature was. You know, the flow meter will say, yes, I've activated. But Insight CIP will tell you, yes, the flow was this and for this duration. So it's a lot more detail. I often describe it as the difference between a photograph of your CIP and a high definition video. And this information can be interpreted to identify where there is overuse. You know, we often find with CIP systems that there is a lot of optimization that can be done. There's a lot of work that can be done to actually improve the system, either looking at where the water and chemical transition takes place via conductivity, so we can see where that interface is between water. So you could be rinsing excessively, so you could be looking to rinse your detergent away. In actual fact, your detergent's gone, and what you're now doing is just pumping fresh water around the system. And SCADA won't necessarily tell you that, whereas Insight CIP will. We can look at water temperature changes between the start and the end of the circuit. And this is important because if you're sustaining temperature loss through your CIP circuit or regime, then the temperature you think you're running at, that your SCADA is telling you you're running at, actually is inaccurate. And you could be actually cooler at the end of the stream than at the beginning of the stream. I've already mentioned excessive rinsing leading to water overuse. And you could have pressure or flow rate changes. So you could see that you have a change in pressure or a change in flow rate. And that can give you an early warning, if you like, an amber light, to say there could be a blockage. There could be inconsistencies in the pipework. You could start to have failures. It's a bit like the rattle in the car. You know, the rattle in the car tells you that something's breaking before it breaks. So it's useful to have that information beforehand in order to make sure that you effectively control your system. planned maintenance is often less expensive and less time consuming than an unplanned shutdown. That information could be provided in either huge amounts of detail that you can spend hours poring over, or as a simple CIP dashboard. And you can also set up independent automatic verification using Insights. You can say, right, we need to run for 20 minutes rinse at 65 degrees Celsius at a 0.5% sodium hydroxide weight concentration. Set those parameters in, and you will get an automatic verification report to ping through to say, yep, we achieve that every time. And that can provide you with a great deal of reassurance and also due diligence should there be a problem later. So interpretation and presentation of that information is important. And we've got Insight CIP running in several plants, one of which has been running for many years and often goes through optimization processes. And this liquid milk plant, in particular, wanted to optimize two streams D and E, in their cream and raw milk plants. They were looking, as we all are, at saving time, water, chemical, and energy resources. As I say, they've had CIP, Insight CIP in for many years, and have done a lot of optimization and continue to receive benefits, even today after it was installed when I joined Christeyns 8 years ago. In 1 month, so this is just July, just on, bear in mind, 2 streams of the CIP. They ran Insight on streams D and E and found that they could achieve a freshwater pre-rinse equivalent in value of about 2,700 sterling. At the moment, the way the pound is performing, that's about the same in every currency, but a volume of water of 570 cubic meters. Recovered water, 15,000. Diluted detergent solution, 18,000. Fresh detergent, 46,000. This is just, bear in mind, in 1 month. So multiply these across the year. So we found a saving on those 2 streams of over 124,000 sterling, which is a figure that any factory, any plant I've ever been to, will absolutely bite your hand off to have that sort of saving handed to them just for 2 of their 16 streams. And it's nearly just over 13,000 meters cubed. Crucially in this, it was also found that by optimizing that CIP, we could hand back just over 7 hours per week when the system should have been cleaning, or should have been producing, but was actually cleaning, to get that the right way around. So when you multiply that up by the operating hours of the weeks of the factory, it's an extra 374 additional production hours per year. As I said earlier, no production manager I've ever spoken to has said, no, I don't need more time. If you can save money, save resources, and hand back time, hygiene will be very, very clearly appreciated by the factory. As I say, there is a full case study that gives more details on this very brief slide. I'll drop that in the chat, and we'll also make that available subsequent to the webinar. We've also have a testimonial from one of our customers, White Farms. So this is from the environmental coordinator, and really the purpose of this is just to show that in that way we've achieved all 5 of our key parameters of being able to reduce the cost of clean, reduce the cleaning time, improve product integrity and quality, environmental footprint, and reduce downtime. And I think the telling comment from Nigel here is the very last sentence, and that he could not envisage running a system without it. So Insight CIP has definitely got a big role to play in helping you to optimize your CIP systems. So thank you very much for your attention. If you have any questions, please pop them in the chat. And I'm handing over to Carmen now.
Yes, I think, Carmen, you will explain us, you will go deeper into automation of processes, and how they can, in fact, have an impact on the resource consumption. So Carmen is export manager for Christeyns Spain. And okay, Carmen, you can take over.
Okay, thank you, Kathleen. Thank you, Peter, for the nice presentation we had. Now it's my turn, and I'll here in this part of the webinar, I will speak about the automation of the cleaning systems that we normally use to improve hygiene results while saving costs. And and some of the examples of the automatic systems that we use are the cleaning and disinfection of conveyor belts and the sanitation of hooks based on the ultrasonic technology. We all know when it comes to cleaning conveyor belts, we could say that most of the times they are not properly cleaned mainly due to the lack of hygiene design. For example, some conveyor belts, they are made of different kind of materials that they have holes, or the impossibility to dismantle the different parts of the belts. Or another reason could be that they are very close to the floor, on ensembled one above the other ones. And we also need to consider that the operators need some time to completely clean a line standing in front of the line of the conveyor belt. And bear in mind that the speed of the conveyor belt sometimes can make this process even more difficult. So all these factors may affect to the microbiological results and the resources used, like time, the chemical products, and of course water. So what we are looking here is to automate this process by installing a series of nozzles all along the length and width of the conveyor belt, and this will allow us to position them in a way that the cleaning angle is optimal so that the mechanical energy is directed towards the belt while applying water, the detergent, or the disinfectant. We will use then the correct pressure, chemical, and time that will cover the whole conveyor belt, ensuring that we obtain standard results, and we are not that dependent on human factors. So our ultimate goal here would be saving energy, time, and water and chemical while increasing efficacy again. Now I'm going to play here a video that we will show you how this system works. It's running, right? So as you can see, it consists of a decentralized satellite that is supplying the arcs where the nozzles are situated, over and below the belt. And these arcs are connected to this satellite that is programmable with different functions, so that the sequence of the different phases or the duration of the same can be set. And this system now requires manual operation, with the advantage that the other parts of the room can be cleaned in parallel, performing other disinfection, clean and disinfection tasks. There are two standard models of this system. The basic one, which needs to be fed with pressurized water between 15 to 25 bars, and the complete one, which incorporates a pump capable of delivering up to 300 liters per minute. And those are the different steps that we can program with this system. So moving from manual to automatic system, as you could see, is relatively simple, and it only implies the installation of the arc of nozzles over and below the belt that contains that allows us through the satellite to program the different cleaning procedures and help us to set the time on and off and the required dosage of chemical that will help at the same time to control microbiological results. In this figure, as you can see, we achieve savings in all the steps when using water, of course, because it's one of the main resources that we are going to use during the cleaning operations. Detergent, we save up to 30% as a means, as an average. in liters, and also disinfectant up to 40% during the trials we perform. Same for the microbiological counts. The reduction in both cases to viable counts and enterobacteria, the reduction was extremely high. And we have to say that measure the control of manual cleaning is not that easy as we could reach with this automatic system, where we can control the pump, the pressure of the pump, allowing us to reduce water. We can also control the chemicals, the dosing of the chemicals, and set up to 3 different products per program. And of course, the time that is very valuable for the operators, they can perform other different tasks at the same time. And the most important is that we can reach better hygiene results and standard results over the time. So having said that, we move on to the next automatic system that consists about the sanitation of hooks based on ultrasonic technology. And like conveyor belts, we can also find that other elements or equipment present in the food industry are key for the production processes, but are very difficult to clean due to their morphology, because they have many angles. They are difficult to clean. And a clear example of this is the line of hooks that we can find, for instance, in the poultry sector. They are considered like a critical point and should be cleaned on a daily basis, but it's very difficult to clean in a whole day the whole line of hooks. This is why with this system that we are going to see next slide, a short video of how it works, we will even increase the efficiency of the operation by saving time, again, chemicals, and the use of water. Ultrasonic cleaning technology, it's the perfect solution for this, because it brings us a synergy, a combination that allows us applying the mechanical energy provided by the ultrasound waves to use the right temperature. We can always set the temperature that we want to clean during the program, and also use the proper chemicals that allow us to properly cavitate. And with this, we can even increase the results and by removing the dirtiest elements, and at the same time start with the disinfection. Those are the different methods we use. We use the static cleaner and the full automatic cleaning system. And in this video, we can see how the sanitation of the different types of hooks is automatic. Sometimes we need to adapt this the line of the customer in order to achieve this structure. And the system also allows us to clean other elements of the production process, like knife or tries, as you will see later on in this video. And the good thing is that while you are using this equipment, there is no need to stop the production process. And this guarantees that the elements cannot increase the microbiological load all along the production, increasing the shelf life of the products and the safety of the food that we later will eat. So this graph describes the tests that we perform on the premises of several customers. This is the case of meat industry, where we can see the difference between before and after the treatment with the ultrasonic technology. And as you can see, we achieve a very nice reduction in aerobic enterobacteria and listeria counts. And this was only by placing the equipment at the right temperature, at 80 normally, and only with 12 seconds we obtain these fantastic results. The same for other items that we clean in the static bath. In this graph, we can see the results before and after cleaning with the ultrasonic equipment. And in both cases, for aerobic, mesophilic, and enterobacterial phase, we achieve a very nice reduction. So as many advantages as we already explained in this presentation and in the past one, by introducing the automatic system, we can not only reduce the time of our operators by implementing other tasks, we also achieve more optimal results, microbiological results, and we at the same time save water, energy, and chemicals. These applications this technology can be also applied to the hooks that we already explained in different meat areas, in boxes, in the meats, or trays in the bakery sector, or cheese molds like crates, ham hangers, or other utensils. All in all, what we can summarize here in this screen that mainly in both cases, not only in cleaning belt conveyors, but also in ultrasonic technology, we can save, we can use less chemicals, less energy, less water, less labor, and less downtime, and of course, effluents. And at the end, this represents an average of 30% of savings. So it's all for my side. Thank you, Kathleen.
Thank you, Carmen. I think the previous presentations have already shown you a lot of possibilities to optimize cost by implementing systems or by just to observation or by changing process parameters. But I think what is even as important is to control the hygiene once you have done some changes. So Maria Sanz, who is R&D Manager Microbiology, she will present us now some possibilities to have a very fast and effective control of hygiene and biofilms. Maria, it's up to you.
Or maybe good afternoon to everyone. I am going to introduce you the next presentation regarding to hygiene control tools. I would like to start with this slide because the first thing that comes to my mind when I am thinking about food industry is that there is not only just one food industry. There are a lot of kinds of food industries, and each one has their specific conditions, their specific environments, and their specific characteristics. So these specific environments, these environmental conditions, including pH, temperature of water activity, are specific of each food industries, but in the vast majority of cases, favors the microbial growth. As you know, in food industries, we have different sources of microorganisms, and if the environmental conditions are able to favor their growth, finally, we have a microbial specific diversity typical for each food industry. So if the environmental conditions inside of food industries are able to promote the microbial growth, and also we have a poor hygiene, it produces the microbial survival. And if there are microbial survival, we have a problem because in this point, it starts a trickle-down effect because the survivors, among the survivors, always there are biofilm-forming microorganisms, and this biofilm-forming starts to form a biofilm and start to produce the matrix. And also the other ones who are not biofilm-forming microorganisms can take profit, take advantage of the formed biofilms and set up inside of these biofilms and to be protected by this matrix. So inside of our biofilms, we find a lot of species inside of a matrix. And this matrix protects them. Protects them because the matrix reduces the dispersion of the biocides, of the disinfectants, and it protects the microorganisms and allows them to survive to cleaning and disinfection procedures. And then finally, we have microorganisms that are adapted to our food conditions, to our food industry conditions, and these microorganisms become persistent. And they can remain in our food industry for days, months, or years. Well, where we can find the microbial contamination? Usually, we find microbial contamination in the areas when it is difficult to clean or disinfect. But also, we can find microbial contamination or biofilm formation in irregular or damaged surfaces or old surfaces, because these irregularities promote the microbial attachment. And also inside of the equipment, because if the equipment is not disassembled in the clean and disinfection procedures, inside of the equipment can grow microorganisms, and also these microorganisms can develop biofilms. So what can we do? So as my colleagues have said before, we can specifically cherry pick the best chemical products. Also, we can optimize the clean and disinfection procedures in CIP and OPC facilities. And also, we can introduce new equipment in order to improve our clean and disinfection procedures. But now I would like to add another factor, and it is the prevention. Coming back to the previous scheme, if we are able to prevent, if we are able to detect the microbial survivals, we can stop this trickle-down effect, and we can avoid serious problems for our food industry. How can I prevent the microbial contamination? Here we have some recommendations. We need a suitable design of the facilities and the equipment in food industries for easy cleaning and disinfection, because in the vast majority of cases, the facilities and the equipment are designed thinking about the production procedure and not thinking about cleaning and disinfection procedure. And we need to understand the cleaning and disinfection procedure as a part of the production procedure. Also, the application of the correct cleaning and disinfection programs specific for each food industry. Minimize the splashing and wetting surfaces during the food production, because in this kind of environments, microorganisms can grow easily. Control of aerosols during cleaning and disinfection procedures in order to avoid the sedimentation. Identify the areas when it is difficult to clean and disinfect, because in these areas is most favorable to develop a biofilm. And disassemble the equipment for cleaning and disinfection in order to avoid the biofilm formation inside of the equipment. Well, up to now, we have been detecting the microbial contamination using contact slides, wipes, swabs, or ATP. But now, I would like to introduce you new control hygiene tools. They are BioFinder and TBF 300. The first one, BioFinder, is a hygiene detection test. It detects the catalase positive microorganisms and also the organic residues with catalase. It can be used in any kind of surfaces, vertical and horizontal surfaces, and also in porous and non-porous surfaces. It is easy to rinse, and we have to apply it carefully. And it's very important to do not shake the bottle before the application. Its detection limit is 10 to 4 cells per quarter centimeter, and the positive result appears like that. As you can see in the picture, it is an orange liquid, and if it is a positive result, appears bubbles. The process of application is very easy. As you can see in the video, you only have to spray the product on a surface, like in the video, and then we spend 1 minute and check. If there are bubbles, it means that the hygiene is not enough and we need to clean again. And then the other hygiene control tool, the TBF 300. TBF 300 is a biofilm detector. It is based in a specific stain for the biofilm matrix. The matrix is staining like that, pink. It can be used in vertical and horizontal surfaces. And it's very important that we cannot use in plastic or permeable materials. We need to use it only in metallic and non-porous surfaces. The process of application is also very easy. As you can see in the video, we spray the product in the surface and extend it. We wait 5 minutes, and then we rinse with water without pressure. And then we check. If there are a persistent pink color, it means that we have a biofilm. A positive result appears like that. It's, as you can see, it's very easy to identify a biofilm because it remains pink. And then these tables allow us a good insight about the advantages of using these new hygiene control tools. If we focus on the hygiene control Biofinder, Biofinder is it allows us to be a result very fast, only in one minute, and also the price per sample is reduced. It's very cheap, so it is faster and cheaper than the previous tools to detect hygiene to detect microbial contamination. And now, if we focus on the biofilm detection, I have to emphasize in this point that the previous tools that we had to detect biofilms was microscopy, basically, or maybe spectroscopy. They are techniques that are only available in universities and in technological centers, and they required for specific microscopies, specific equipment, specialized technicians, and also the process to detect a biofilm is very expensive. So TBF 300 allows us to detect a biofilm only in a few minutes, in situ, in food industry, and with a reduced price. So both Biofinder and TBF are low-cost tools to detect microbial contamination, and they can be used in situ in food industry. And finally, to sum up my presentation, we have new hygiene control tools, and it allows us to detect microbial contamination early. And if we are able to detect it early, we save time and cost. We save time because if the detection is in a few minutes, we have the capacity to react very quickly in order to avoid serious problems. And also, if they are cheaper, it allows us to use it frequently with a continuous monitoring of our facilities, and it allows us to react if we have a problem and avoid higher problem of food safety, food security, food quality, economical losses, and of course, it avoids to smudge our reputation. And that's all for my part. Thank you very much for your attending.
Okay, thank you very much, Maria. I think we go now over to Lieslot, who will return. In the invitation, it was said tips which you can implement already this afternoon. So I think she's gonna give you some homework. Lieslot, you can take over.
On a Friday, that's really...
Yeah.
Okay, no, indeed, I think we got quite a lot of options or possibilities, maybe a little bit of an overload. So actually we wanted to finish this webinar with some practical tips and tricks that you can apply this afternoon or start your next week, Monday, in a very sensible way by checking these things. So again, we will follow a bit the structure of the Sinner Circle, because I mentioned before, this is a nice guidance in this whole process. So concerning time, some practical, a very simple thing to do is actually go to validate the rinsing times through checking the pH, conductivity, and maybe also based on ATP measurements. To see if you can reduce rinsing times. You know, this installation or rinsing with fresh water takes a lot of fresh water, so you could a few seconds of saving on the time can indicate or can result in a really massive saving on water. Then for OPC, so open plant cleaning, another thing we see a lot is actually people have the habit to rinse the floors a lot during the OPC cleaning. Each time they rinse the machine, they rinse or clean the floor. Actually, if they wait to rinse the floor of the production area at the end of cleaning all the machines, you save as well time and also of course also some water. And then what was mentioned before, also the foam, respect the contact times, so let the foam do its job, but also make sure that it doesn't dry on the surface. Dried foam takes a lot of more time and water to remove all the residues of the soiling, but as well of the detergents afterwards. And again, respect contact times, especially for disinfectants, also mentioned before by Karin. That's a very important one, is to respect and use disinfectants in a correct way. Then a few tips specifically for water and energy. Of course, everything is always a bit related to each other. But for example, the water temperature, people think they always need very hot water, but actually it's to consider which is the optimum water temperature for your kind of soiling. On one hand, too hot water will also cause more lime deposits, but on the other hand, for example, pork fat has a melting point of 30 degrees. Then it makes sense that you don't clean at 50 degrees. You can also have good results between 35-40 degrees. 10% decrease in water temperature gives a nice saving on energy. Use the correct nozzles. Once again, we can't repeat it enough. Use correct nozzles, no open hoses or use without nozzles. You see that just removing the nozzle can multiply or actually double the water consumption. So these are like small changes you can do which have a very big effect on the water reduction. And as well, hot water reduction, of course. Use squeegees to remove big pieces. Also, something we see quite a lot is that people use water as a transport medium to remove or to transport big pieces of soiling, but you have to remember anyway, in the end, you have to pick them up from the drains. So then just use a squeegee to bring them together and pick them up before you start rinsing. Leak prevention. Also, it's more from the maintenance part or for the maintenance people, but a tap who loses one drop or who releases one drop of water a second, that results in actually 11 cubic of water wasted per year. So that's also, if you imagine in your factory, you see all the leaks, you can start counting how much water you waste through them per year. And then specifically for CIP and crate wash applications, again, rinsing times. Rinsing is not only saving time, but also water, reducing the rinsing time. Foam control, also overflow or over-foaming is resulting in a lot of loss of water, but also detergents that will be lost and redosed, and also could result in the decrease of cleaning results due to different flows in your installation. And then to end, also reuse and redistribution of rinsing water. People try to reuse as much water as possible, but sometimes you have to consider sending fresh rinsing water to, for example, a detergent tank. Then you are refreshing your detergent tank maybe more than what's necessary. And if he moves, oh, okay. Yeah. And then concerning disinfectants or biocides, a tip we want to give is really check the claims that you need and the use conditions. The target organisms, you don't need to use disinfectants or at concentrations or conditions to kill fungi or viruses, while you only want to kill or you only have to reduce the bacteria. Often those bacteria conditions are much shorter contact times or lower dosings than the ones you maybe use every day. And also, I'm starting to talk French now. Okay, this is going good. Advised concentration. So watch out for overdosing. All the products, if they pass at 0.5%, they are validated at 0.5%, and it doesn't make any sense to dose them at 1%. Another tip we want to give is the no rinse approval. Some products have the approval to apply without rinsing. To do it without rinsing in reality might save you a lot of time and water as well, of course. Then the effect of overdosing again. It's not only maybe an overdosing and not necessary for the efficacy, but also on your expenses. This can have a big result. For example, if you have a crate washer, for example, that should be dosing or should be running on 0.5%. If you dose at 1%, in your mind it might be only 0.5% of difference. But if this crate wash is consuming 15,000 euro at 0.5%, then if you do it at 1%, it's 30,000 euros. So this 0.5% can give a big difference in expenses. Then mechanical action, some last tips to give, or things we see quite often going wrong. Give the products the time to react. Don't foam and rinse after 5 seconds. For example, if you have a burned saucepan at home, you also soak it first before you start rubbing. The people who tried rubbing in the past know it takes quite a lot more time to remove the soiling instead of just giving it a moment to soak and rub afterwards. Crate washers, check the positioning and missing or blocking nozzles. This is a very easy thing to do, but we also see that it happens very, very rare. It's a 2 seconds or a 1 minute check every day, but it can improve your washing results, of course, a lot, and also could save a lot of time and all other kinds of problems, water wasting and everything. Then the last one, again, OPC, we can't repeat it enough. Use the correct nozzles for the mechanical action. Also to make sure that all the people who are cleaning in the same factory keep up with the good and the same pressure. And also for water wastage, and of course, in the end, mechanical action. So that's it. We are a bit past time, but for a conclusion, or where we want to end with, actually that the goal of today was to show that we can offer more than just chemical solutions. We have a lot of expertise and options in-house to change things on all the other points as well. So we hope we can help you with these things and not only with the chemicals in the future.
Thank you.